Today we are going to discuss chemical equation, chemical reactions, and balance equation. Let's review the concept of chemical bonds. We know the atoms gain or lose electrons through chemical reactions to fill the outer shell in order to be stable. It means they become more like nearest noble gas. When chemical reactions occur, it forms a chemical bond, which is an attractive force that holds atoms together in a new compound. We discussed two kinds of chemical bonds: ionic bonding, in which the electrons are transferred from one atom to another atom. In this example, sodium is transferred one electron to chlorine to be more stable and form sodium chloride. In the case of the covalent bonds, the atoms share the electrons to be more stable. It means to achieve the noble gas configuration. In this case, we had chlorine, and they share one electron to form the chlorine molecule. To represent the chemical reactions, we use the chemical equations. In the first example, the equation indicates that one molecule of hydrogen gas reacts with one molecule of chlorine gas to form two molecules of hydrogen chloride. In the second example, we can see two molecules of hydrogen gas react with one molecule of oxygen gas to form two molecules of water vapor. So chemical reactions occur when the bonds between the outermost electrons of the atoms are formed or broken. Also, chemical reactions involve change in matter. They make the new materials with the new properties. And we can describe chemical reactions using chemical equations. There are different ways to describe a chemical reaction. For example, we can use words. We can say, in this case, methane reacts with oxygen to yield carbon dioxide and water. We can also describe the chemical reaction using an equation. We can see the equation had two parts, the reactants and the products. In this case, in the reactants part, we had the methane, we had the oxygen, and they react to form carbon dioxide and water. We can use also a sketch to represent the molecules. In this case, we had one molecule of methane plus two molecules of oxygen, and the reaction results in one molecule of carbon dioxide plus two molecules of water. We will learn how to write and balance the equation of chemical reactions. Let's identify the meaning of the symbols used to write a chemical equation. For example, the subscript numbers are part of the formula of the substance. In this case, the subscript numbers are the blue one. For example, 4 is part of the formula of the methane, and 2 is part of the formula of the oxygen molecule. The same in the case of the products. 2 is part of the formula of the carbon dioxide, and 2 is part of the formula of the water. The italicized letters, which are in parentheses, indicate the physical state. For example, S corresponds to solid, L corresponds to liquid, G corresponds to gas, and AQ corresponds to aqueous, and it means can dissolve in water. The green numbers are the coefficients. The coefficients are in front of the formula. They are not part of the formula. They are usually used to balance the equation. Also, it is important to know a chemical equation is balanced if the total number of each kind of atom is the same on the left-hand side and the right-hand side of the equation. One example of chemical reaction is the photosynthesis. when water reacts with carbon dioxide plus solar energy, they produce glucose plus oxygen. The reverse chemical reaction can also happen. If a plant material reacts with oxygen, they produce water plus energy plus carbon dioxide. For example, if the wood burns, it produces water, energy, and carbon dioxide. Let's write the equation of this reaction. Now we are going to balance the equation of the photosynthesis reaction. It means we want to get the same number of atoms on each side of the equation. Then let's first write the equation. We had water which is liquid plus carbon dioxide which is gas plus energy. The way we indicate energy, we can use the triangle to indicate we need to add energy to the reaction. And then in the product we had glucose usually is solid plus 1 molecule of oxygen which is gas. The next thing we want to do is we want to balance the equation. Then to do that, let's write in a table the atoms are involved in the reaction. Then we had hydrogen, we had oxygen, and we had carbon. And we want the same number of atoms in the reactants and the same number of atoms in the products. Then let's start with hydrogen. We had here 2 hydrogens, but on the other side we had 12 hydrogens. Then what we need to do in order to get the same number of hydrogens, we need to multiply this molecule by the water molecule by 6. In this way, if we multiply 6 times 2, we will get 12, and on this side we had 12 hydrogens. Then now we can write here we had 12 and 12. Now let's see with what happened with oxygen. On this side we had 6 times 1 is 6, then we had 6 plus 2, we had 8 oxygens. On this side we had 6 plus 2, 8. Then now for now we had 8 oxygens on each side of the equation. Sometimes you need to change that number. Then now let's see what happened with carbon. We had 1 carbon here, but on this side we had 6 carbons. Then what we need to do is we need to multiply the carbon dioxide molecule by 6 in order to get 6 carbon. Now we had 6 times 1 is 6, and we had 6 carbons here. Then we had carbon 6 here. But because we multiplied the whole carbon dioxide molecule by 6, we need to check again the number of oxygens we had on each side of the equation. And let's see, in this side we had 6. Remember, 6 times 1 is 6. 6 times 2 is 12. Then 6 plus 12 is 18. And let's see on the other side how many oxygens we had. We had 6 plus 2 is 8. Then we need 18. Then we need to do something. What to do? We need to multiply by 6 here. And we need to multiply these molecules. 6 times 2 is 12 plus 6, 18. And we had the same number on the reactant side. 6 times 2 is 6. 6 times 2 is 12. 6 plus 12, 18. 18 and 18. Now we had the same number of atoms on both sides of the equation, and this is the balance equation of the photosynthesis reaction. There is no any rule to balance the equation. It's just trial and error. This is the method to balance any chemical reaction equation. In the next slide, we are going to answer these two questions. How can you tell a chemical reaction is occurring? What observations may you make? In this picture, we can see a clear solution of magnesium iodide reacts with a clear solution of silver nitrate, producing a precipitate of silver iodide. We can see during chemical reaction there is a change in color, and also there is formation of precipitation. So we can say a chemical reaction occurs if there is a change in color or formation of solid, means there is a precipitation. Also, a chemical reaction occurs if there is formation of gas, for example, when bubbles are present during the reaction, or if the solution gets hot or cold. Here we had some examples of signs that indicate the solution has taken place. In the first example, we can see when colorless hydrochloric acid is added to a red solution of cobalt-2 nitrate, the solution turns blue, means there is a color change. In a second example, we can see a solid forms when a solution of sodium dichromate is added to a solution of lead nitrate. In the third example, we can see there is a bubbles of hydrogen gas when the calcium metal react with water. In the last picture, we can see the methane gas react with oxygen to produce a flame in a Bunsen burner. Now let's try to answer this question. How can you predict the products of a chemical reaction and their physical state? To answer this question, we will follow these 4 steps. First, we will identify the type of ions present in the solution. The second step is rearrange the ions to form neutral products. And the step number 3 will be determine the physical state of each product. And finally, in the step number 4, we will balance the chemical equation. Let's start. In these examples, we want to predict the products, in this case 2 products, if magnesium chloride reacts with sodium hydroxide. Then let's start with the step number 1. We want to identify the type of ions present in the solution. And in this case, we want to identify the ions present in the reactants. Then we had magnesium, we had chlorine, we had sodium, and we had hydroxide. Then let's write this ions here. We had magnesium, we had chlorine, we had sodium, and we had the hydroxide group. To know the charge of each of these ions, we will use the periodic table and the table in which we had the polyatomic ions. And in case of the magnesium, we can see magnesium is +2 because it's in the second column. Then magnesium is +2. Chlorine is -1. Sodium is +1. It's in the first group. And hydroxide is -1. Now the next thing is we need to rearrange the ions to form neutral compounds. Then always the positive ions we will react with the negative ion. Yes. This is one reactant, and this is the other reactant. And let's right here is one line to separate these two. And always the positive ion will be react with the negative ion of the with the negative ion of the other reactant. Then positive will be react with the negative. And in this case, chlorine will be react with sodium. Remember, positive and negative charge they attract, and like charge they repel. And this is why always the positive will be react with the negative ion. And now right here the ions. Remember, always we will write the metal and then the non-metal. And we will write here magnesium, which is +2, with hydroxide, which is -1. And the other product will be sodium. Remember, always the positive ion of the metal, which is +1, and then the chlorine, which is -1. Now we need to check if the products are neutral. And we can see here we had +2, but here we had -1. Then we need to hydroxides to get -2. Then the product will be magnesium hydroxide. You can see in the final products we don't use any charge. It's just we write the formula. In this case we had sodium is +1, chlorine is -1. They are neutral. Then just we need to write, and this is and now we had two products. We had magnesium hydroxide and sodium chloride. Then let's now move to the step number 3. We need to determine the physical state for each product. To do that, then we will write the complete equation. Then let's start with the reactants. And we had magnesium, is AQ, and then now we will write the products we got. Then we had magnesium, plus, let me give here some space to write the physical state for the product. Here we will write the physical state for this product, plus, then we had sodium. Here we will write the physical state for this product. To determine the physical state, we will use this table, which is in your equation sheet. Then we will find where is magnesium and hydroxide group. And we have magnesium here, and then yes, you move to find the hydroxide. Then if you combine magnesium with hydroxide, you will get insoluble, means you will get a solid state. Then in this case, if magnesium hydroxide is forming, then you will get solid product in this case. Let's see what happened with sodium chloride. Then sodium chloride. Here we have chloride. We have sodium here. Then is A. A means is soluble, means is AQ. And to determine the physical state, we will use the table is in your equation sheet. Now we are going to move to the step number 4. We want to balance the equation. It means we need to get the same number of each kind of iron on both sides of the equation. Then to do that, we know there is no any procedure, there is no any rule, just we will use the method of trial and error. And let's write first the atoms we had in the equation. We had magnesium, then we had chlorine, we had sodium, then we had oxygen, and we had hydrogen. And here we will write the number of atoms we had in the reactants, and here we will write the number of ions we had in the products. Then let's start. Magnesium. On this side we had 1 magnesium, and on the other side we had 1. Then no problem, we had 1 and 1. Then let's write. Let's see with chlorine. We had 2 chlorines here, but in this side we had just 1. Then in order to get the same number of chlorine on both sides, we need to multiply sodium chloride by 2. Then now we will have 2 here, and we will have 2 times 1 is 2. And we have 2 and 2 on both sides of the equation. And now let's see what happened with sodium. In case of the sodium, we had 1 here and we had 2 here. Then to get 2 sodiums on both sides, we need to multiply sodium hydroxide by 2. Then now we had 2 sodiums on the product side, and we had 2 sodiums in the reactant side and 2 sodiums in the product side. Now let's see what happened with the oxygen. Remember, this 2 multiply all this equation. Then we had 2 times 1 will be 2. Then we had 2 oxygens on this side, and on the other side we had 2 oxygens because we had 2 hydroxides. Yes, we had 2 oxygens. Let's see how many hydrogens we had here. In this case, remember, these 2 multiply the whole molecule, then 2 times 1 will be 2. Let's see how many hydrogens on this side. We had 2 hydrogens. We had the same number of atoms in each side of the equation, means the equation is balanced. Then this is the final result. This is the equation that describes this chemical reaction. In this example, we want to find what are the products that result when calcium chloride react with sodium carbonate. Then let's start with the step number 1. And let's write the ions in each case. Then we had calcium, we had chlorine, we had sodium, and we had carbonate. To know the charge of each of these ions, we will use the periodic table. And in case of the calcium, we can see calcium is in the second group, then calcium is positive 2. Chlorine is in the 7th group, and this is why it's negative 1. Sodium is in the first group, and this is why sodium is positive 1. And carbonate is a polyatomic ion, and the charge is negative 2. Now let's combine the ions. We know the ions will be combined always positive with negative ions, because positive and negative, they attract. Then calcium will react with carbonate, and chlorine will be react with sodium. Then in the step number 2, we want to write what are the products. but we need to find neutral products. And now let's write here. The products will be calcium, which is +2, and carbonate, which is -2. And the other product will be sodium. Remember, always the metal or the positive ion is first, and then the non-metal or the negative ion. And let's check if we had neutral products. And we had +2 here, -2 is neutral. And now we can write the final product without any charge. Let's see the other product. We had positive here, we had negative here, is neutral, then now we can write the final product. Once we had the final product, then we can move to the step number 3. We want to determine the physical state of each of the products. And to do that, we need to write the complete equation. And let's write the reactants first. And now we will write the products. And it's calcium plus sodium chloride. To find the physical state of the products, we will use this table, which is in your equation sheet. It's the table of the solubilities in water, and we will use this table to find the physical state for the products in the chemical reactions. Then calcium, then we will identify calcium here, and then carbonate, calcium, carbonate, and we have C is I, then I is insoluble, then is solid. Then sodium, we'll check where is sodium chloride, and we can see is A means is soluble, then is AQ. And now we complete the step number 3, and we move to the step number 4. In the step number 4, we need to get the same number of atoms on each side of the equation. And let's write the list of all the atoms we had in the reactions. Then we had calcium, we had chloride, we had sodium, we had carbon, we had oxygen. And let's make the list for the reactants and for the products. And let's start. We had 1 calcium on this side of the equation, and we had 1 calcium here. Then we had 1 here, 1 here. In case of the chlorine, we had 2 chlorines here, but here we had just 1. Then in order to get the same number of chlorine, we need to multiply all these molecules by 2. Then now we had 2 on this side, 2 times 1 is 2, then we will have 2 and 2. Sodium, we had 2 sodiums here, we had 2 here. Remember to multiply the whole molecule, then 2 and 2. In case of the sodium. Let's see what happened with carbon. We had 1 carbon here, 1 carbon here. There's no problem with carbon. Now let's see oxygen. We had 3 oxygens here, and we had 3 oxygens here. Then this is the balance equation when calcium chloride reacts with sodium carbonate. Let's try one more example. In this case, we had calcium carbonate plus hydrochloric acid, and we want to find the three products that result when these two compounds react. And let's start with the step number 1. And we want to identify the ions present in the solution. Let's see, we had calcium, we had carbonate, which is a polyatomic ion, we had hydrogen, and we had chlorine. To get the charge of each of these ions, we will use the periodic table and the table for polyatomic ions. And let's see, in case of calcium, calcium is in the second group, then this is why calcium is +2. Carbonate, the charge of carbonate is -2. We can see in the table. Then for hydrogen, hydrogen is in the first group. This is why the charge of the hydrogen is +1. And in case of the chlorine, is in the 7th group, and this is why chlorine is -1. Now let's combine these two groups of ions. We know the positive ions will be react always with the negative ion because they attract. Then calcium will combine with chlorine and carbonate will be combined with hydrogen. And in the step number 2, we want to write the neutral compounds. Then let's start with the first one is calcium. Always we will write first the positive charge of the metal and then the negative charge of the non-metal. In this case is chlorine. Here we will write first hydrogen and then carbonate, which is -2. We need to check if we had neutral products. And we can see here we had +2, but on this side we had -1. Then in order to get the same charge, we need 2 chlorine here. And now if you multiply 2 minus 1, you will get -2. Now we have neutral product, and we can write the final product or the neutral product without charges. In the second product, we had +1 here, and here we had -2. Then we can see we don't have neutral product. Then to get neutral product, we need to add 1 more hydrogen. Now 2 plus 1 will be +2. Now we have neutral product, and we can write here the final product without any charge. And now we can move to the step number 3. And in this step, we want to find the physical state of the product. And let's write the complete equation. We will start with the reactants. Then we have calcium, carbonate, plus hydrochloric acid, which is AQ. And then we need to write the products. We can see according to the problem, we need to find 3 products, but here we have just 2. What happens is usually this product is not in this form. This product is usually present as this form. Water plus carbon dioxide. And you can see we had 2 hydrogens here, we had 2 hydrogens. We had 1 carbon, and we had 3 oxygens. 1 plus 2 is 3. Then we had 3 oxygen. And this is why now we have 3 products. We had 1, 2, 3 products. And let's write the products here. Calcium plus water plus carbon dioxide. And to check the physical state, we will use this table. And let's see what happened with calcium chloride. Is A, which is AQ. Yes. Water usually is liquid and carbon dioxide is gas. And we complete the step number 3, and now we move to the step number 4. We need to balance the equation. To balance the equation, we need to write the list of all the atoms present in the reaction. Then we had calcium, we had carbon, we had oxygen, we had hydrogen, we had chlorine. This is all the atoms we have. Now we will make the list of the number of atoms in case of the reactants and the products. And let's see. We had one calcium here, then no problem with calcium. We had the same number of calcium on both sides of the equation. Now carbon, we had one carbon here, we had one carbon here. Oxygen, let's see, we had 3 oxygens here, we had 1 here, plus 2, 3 oxygens. We had 3 and 3 oxygens. Now let's see what happened with hydrogen. Now let's see what happened with hydrogen. In case of the hydrogen, we had 1 hydrogen here, we had 2 hydrogens here. Then in order to get the same number of hydrogen on both sides, we need to multiply the hydrochloric acid molecule by 2. Now we had 2 hydrogens and 2 hydrogens on this side. Now let's see what happened with chlorine. We had 2 chlorines here because remember these 2 multiplied to whole molecule, then 2 times 1 is 2, and on this side we had 2 chlorines, then we had 2 and 2. And we can see we had the same number of atoms on the reactant side, and we had the same number of atoms in the product side. Then now the equation is balanced, and this is the chemical reaction equation that resolves when calcium carbonate reacts with hydrochloric acid. Now in this example we need to find the products when acetic acid reacts with sodium carbonate. And let's start with the step number 1. We want to identify the ions. Let's start with the step number 1. We need to identify the ions. We had hydrogen, we had acetate, which is a polyatomic ion, and in the other reactant we had sodium and we had carbonate. And let's see what is the chart for each of these ions. And in case of hydrogen, hydrogen is in the first group, and this is why it's positive 1. In case of the acetate, we can see the charge is negative 1. For sodium, it's in the first group. This is why it's +1. And carbonate, which is also a polyatomic ion, the charge is -2. Now we need to combine the ions. Then we know the positive ion will be combined with the negative ion, and the negative ion will be combined with positive ion. Now in the step number 2, we need to write the neutral products. Hydrogen react with carbonate, and we know hydrogen is +1 and carbonate is -2. The other product we had is sodium. Remember, the positive ion is always first, and then the acetate. Sodium is +1 and acetate is -1. Now let's see if we had neutral compounds. Then we had hydrogen, and hydrogen is +1 and carbonate is -2. We can see they are non-neutral, then we need one more hydrogen to get neutral compound. Then we need to add 2 here, then 2 times 1 will be +2. Now we had neutral compound, and in this case we had +1, we had -1, they are neutral. Then we don't need to do anything for the second product. But we said in the previous example that usually this compound is not in this form. Usually this is like water plus carbon dioxide. And let's write the second product. And now we had 1, 2, 3 products. And now we can move to the step number 3. And let's write the complete equation, and then we need to find the physical state for each of the products. And first we write the reactants. Now we write the products. And we had water, and we say usually water is liquid. Here should be 2, not 3, because it's carbon dioxide. Here should be 2, then carbon dioxide, that is gas, and finally we had sodium acetate. And we need to find the physical state. Then let's see in this table what is the state for sodium acetate. Sodium, then we have acetate is A, means it's AQ. Now let's balance the equation. And let's make first the list for all the atoms we had in the equation. Then we had hydrogen, we had carbon, we had oxygen, we had sodium. This is all the atoms we had. And let's make the list for the reactants and for the products. Now we can start trying to balance the equation. What we can see is to balance hydrogen is a little complicated because we had here 4 and we had hydrogen in 2 places on the product side. Then in this situation it's better to start with another atom that is easier to balance. For example, in this case it will be easier to balance sodium because we had just sodium on one compound here and we had sodium just in one compound here. Then we need 2 sodiums on the product side because we had 2 sodiums in the reactant side. Then we had 2, and what we need to do is just multiply by 2 the sodium acetate. Then we multiply by 2, we will get the same number of atoms on both sides of the equation. And now we can check hydrogen. And let's see, we had how many hydrogens we had here. We had 4. And how many we had on the product side? We had 2 here. And we had 2 times 3 is 6. 2 plus 6 equals 8. And we had 4 here. Then to get 8, we need to multiply the whole equation by the whole, we need to multiply the whole molecule by 2. Then 2 times 4 is 8. 2 plus 6 is 8. Then we had the same number of hydrogen on both sides of the equation. Let's see carbon. We had 4 carbons here. 2 times 2 is 4. Plus 1 is 5. Let's see on the other side. We had 1. 2 times 2 is 4. 4 carbons plus 1 equal 5. Then we had 5 and 5. We had the same number of carbon on both sides. Let's see now oxygen. 2 times 2 is 4. Plus 3 equals 7. Let's see now what happened with oxygen on this side. We had 1 plus 2 is 3. And 2 times 2 is 4. Then 1 plus 2 is 3 plus 4 equals to 7. Then we had the same number of oxygen on both sides of the equation. Then now we can see the equation is balanced, and this is the equation that resolves when acetic acid reacts with sodium carbonate.